The widespread belief among most researchers is that the speculation of how things came to be remains the major clarification for the early times of the universe. This hypothesis includes the development of stars, planets, and so on, life on those planets, including ourselves. Notwithstanding its odd name, the Big Bang offers an enlightening assessment of what could have occurred. At first, the universe was dense in a short space, more dense than a pinhead, containing densely packed particles. From this moment, a giant explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set up the expansion of vast history. However, advancements in scientific knowledge have led to growing deviations from the assumptions underlying this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever, researchers estimated that its observations would confirm the theory of the early universe's origins. After only 1 year in space, the telescope surprised experts with its ability to peer deeply into the universe's past. The James Webb Telescope's astonishing capabilities have revealed countless galaxies, going as far back as a time so ancient that it challenges our understanding of the universe's origins. This discovery has ignited intense debate concerning what existed before the Big Bang. One key moment in this mission occurred when cosmologist Rohan Natu, working with data from the telescope, unexpectedly discovered a galaxy from just a brief time after the Big Bang, making it the most distant universe ever seen. Natu's discovery sent shockwaves through the scientific community, highlighting the surprising abilities of the James Webb Telescope. Its enormous goal, to reshape our perspective on the universe, has only just begun, promising to uncover stunning insights into the earliest periods of the universe's existence. This period, scarcely studied before, holds the key to understanding the formation of the first stars and galaxies. The telescope's revelations have challenged fundamental theories, uncovering galaxies with features that surpass previous assumptions. This unexpected flood of early galaxies has sparked a storm of scientific inquiry, pushing experts to reconcile these discoveries with existing theories. As researchers grapple with these findings, they face fundamental questions about the very nature of the universe and the forces that shaped its development. Beyond its scientific advancements, the James Webb Telescope remains an engineering marvel, positioned 1.5 million kilometers away from Earth, protected from ordinary interference, and cooled to near absolute zero by its tennis court-sized sunshield. It incorporates a massive segmented mirror and incredibly sensitive instruments designed to reveal previously hidden details of the early universe. This period, known as the Cosmic Dawn, occurred around 200 to 300 million years after the Big Bang, when the first stars and galaxies began to form. The exact process by which this unfolded remains a subject of intense investigation, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the cosmic dawn presents a unique opportunity for cosmologists to test their understanding of these complex elements. By studying these ancient galaxies, scientists can either confirm the validity of their current models or uncover gaps in understanding that could lead to major new discoveries. Initially, the telescope was expected to observe only a few faint and small galaxies in its pilot studies. However, reality has far exceeded these expectations. The telescope's early images of the distant universe revealed an abundance of galaxies with ages, sizes, and brightness levels that defied all predictions. This surprising surge of early galaxies has sparked a race among astronomers to establish new benchmarks for the earliest known cosmic structures. New discoveries are emerging regularly, leaving experts in awe. Following the James Webb Telescope's findings, researchers and observers have rushed to analyze the existence of these unexpectedly advanced early galaxies. Some have hypothesized that errors in interpreting telescope data could be responsible for these startling discoveries. That said, the consensus remains that these revelations represent a paradigm shift in our understanding of the early universe, providing exciting glimpses into its limitless possibilities. The new discoveries from the James Webb Space Telescope have raised key questions about the nature of the universe and challenged the assumptions of standard cosmological models. While some experts are working to reconcile these insights with existing theories, others propose that they may be the first signs that the universe is far more complex and mysterious than previously imagined. The pivotal question at play is our fundamental understanding of how the universe emerged from primordial chaos. The early revelations of the JWST could reshape our essential ideas of cosmic history, uncovering insights not just into distant galaxies and ancient structures but also into the very nature of our own Milky Way. As Mark Makorian, senior scientist for science and exploration at the European Space Agency, puts it, "You don't make these machines to confirm theory, but to break it. You just have no idea how it will break." The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was conceived. Released at the time, G. Weir, then head of STSCI, was tasked with envisioning what might come after Hubble. Despite initial doubts, Weir and a small team began laying the groundwork for what would eventually become the James Webb Space Telescope. In contrast to Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared spectrum, allowing it to peer much further into the universe. This capability is crucial for studying distant galaxies, whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its massive, cold, star-like mirror, the JWST became the premier tool for uncovering the secrets of the cosmic dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field Observation revealed countless galaxies in what was once thought to be a skyless region. This discovery illustrated the richness of the early universe and emphasized the need for a telescope capable of probing much deeper into cosmic history. After 20 arduous years of development and a cost of around $10 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most pivotal year of scientific observations. Initiatives like the Release Science Program and the General Observer Program were specifically designed to search for early galaxies. While initial expectations were modest, the results far outperformed them. JWST observations have tested existing models of the early universe, revealing galaxies that challenge conventional cosmological assumptions. These remarkable discoveries underscore the importance of pushing the boundaries of scientific inquiry and highlight the extraordinary capabilities of cutting-edge technologies like the James Webb Space Telescope. As scientists continue to analyze JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began rolling in from the JWST, cosmologists were eagerly awaiting the results. Many had been anticipating this moment for years, refining their data analysis pipelines in preparation. Instead of following the traditional peer review process, which typically takes months, specialists decided to share their discoveries on preprint servers like R14, a platform for research papers that have not yet been peer-reviewed. This approach allowed for a new form of peer review to take place through social media platforms like Twitter, where established experts could rapidly discuss findings. Rohan Notta described this process as science by press release, and the storm of conversation that followed was both intense and unprecedented. However, concerns arose regarding the potential disadvantages of this rapid spread of results. Klaus Pontoppidan, a JWST project scientist at STSCI, warned that while the quick sharing of results facilitated rapid dissemination and discussion, there was also a risk of overwhelming the process. The general understanding among most experts is that the theory of how the universe came to be remains the fundamental explanation for the early times of the universe. This hypothesis combines the development of stars, planets, and life, including ourselves. Despite its odd name, the Big Bang theory offers a compelling explanation for the possible events at the universe's origins. The universe was once packed tightly into a space smaller than a pinhead, filled with densely packed particles. From this moment, a massive explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the stage for the unfolding of cosmic history. However, changes in scientific knowledge have led to growing anomalies within the assumptions of this theory. When NASA launched the James Webb Space Telescope, the most expansive and advanced space science observatory ever built, researchers speculated that its observations would support the theory of the universe's origin. Unfortunately, after just 1 year in space, the telescope shocked experts with its ability to peer deeply into the universe. The James Webb Space Telescope's remarkable capabilities have revealed galaxies dating back to such ancient times that they challenge our understanding of the universe's origins. This discovery has sparked a serious investigation into what may have existed before the Big Bang. As astronomers sift through the JWST's groundbreaking data, new questions emerge about the fundamental nature of the cosmos. If galaxies existed earlier than expected, what does that imply about the formation of the first stars and the evolution of cosmic structure? Some researchers speculate that our current models may need significant adjustments, or even a paradigm shift, to fully accommodate these findings. One of the most striking revelations from the JWST is the discovery of galaxies that appear far more massive and mature than conventional models predicted for the early universe. The presence of such well-formed structures at an epoch when the universe was still in its infancy suggests that star formation and galaxy assembly may have proceeded much faster than previously thought. This challenges long-standing assumptions about the timeline of cosmic evolution. Moreover, JWST has provided unprecedented insights into exoplanets, planets orbiting stars outside our solar system. By analyzing the atmospheres of these distant worlds, scientists can search for signs of habitability and even potential biosignatures. The telescope's ability to detect molecular compositions in exoplanet atmospheres is already transforming our understanding of planetary systems and their potential to harbor life. Despite its success, the JWST's discoveries have also reignited debates within the scientific community. Some argue that the anomalies observed in the early universe may indicate the need for new physics, while others caution against premature conclusions, emphasizing the importance of refining data and exploring alternative explanations. Regardless, the telescope's revelations ensure that the coming years will be a golden era of discovery, where theories are tested, revised, and perhaps rewritten. As JWST continues to operate, future missions are already being planned to complement its work. Proposed telescopes, such as the Habitable Worlds Observatory, aim to build upon JWST's legacy by directly imaging Earth-like exoplanets and further unraveling the mysteries of the cosmos. The journey of cosmic exploration is far from over. In fact, it has only just begun.